Maggie. The change in y over the change in x is one way of looking at it. The other way is just the formula, Lydia. Right. That's the formula we're going to use. Maggie's right, though. That's the change in y over the change in x. Okay? So calculating the average rate of change over the intervals given. So in this first one, we're shown a function. We're asked for the average rate of change from an x of 0, find that point right here, to an x of 4. 1, 2, 3, 4, that point is there. So if you want to, just tell me the coordinates. We have 0, 1, and 4, comma 7. Am I counting that right? And then just do your slope formula. Your second y coordinate 7 minus your first y coordinate 1. 7 minus 1 over your second x coordinate 4 minus your first x coordinate 0. 4 minus 0 and reduce. You get 6 over 4, which reduces to 3/2. Any questions on that? Okay. We're also going to do, let's do 7 to 13. So 5, we'll do part 3. So 4, 5, 6, 7, that's this point. So that's 7, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To 13, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our slope for that is going to be 15 minus 10. That's y minus y. Over 13 minus 7. That's x minus x. So we get 5 over 6. Okay? The next part below, still applying to this problem, using a straight edge, draw the lines whose slopes we found. We only found the first and the third. So I'm going to connect these two with a straight line and connect these two with a straight line. Now, looking at the two straight lines, which one is a greater average rate of change? The first one, because if you're just looking at it, this line is slightly what compared to this one? Steeper. The steeper the line, the larger the slope, the further away from 0 it is. So you can see that reflected because this 3 over 2 is technically 1.5, which is a bigger number than 5, 6. 5, 6 is the decimal 0.83 repeating. So the magnitude of this one is bigger than this one, which is reflected in a steeper slope. Okay? That should be review. Jump down to exercise 2, where we are not given a picture. We are given function rules. We have an f function and we have a g function. And in part A, we'll just do part A, and we'll do it for the f of x function. They want the average rate of change from -2 to 3 on the f function. Okay? Again, we're not shown a picture, so we can't just go grab the points off of a picture and count. But how can we get the points? Starting with an x of -2, how do we get the y coordinate that goes with that? If we're dealing with the f function, what do we do with -2 to get the y coordinate? Let's go. Plug it in. 5 times -2 is -10. -10 plus 7 is -3. So there's the first point we're starting with. And we want this interval to end at 3 on the f function. So you plug in 3 on the f function, you're going to get 15 plus 7, which is 22. So if you're given an equation, find your own endpoints. And then do your slope formula. 22 minus -3, 3 minus -2. The double negatives in both cases turn to plus. And we get 25 over 5, which is 5. Okay? So, if I were, I'm just going to kind of help you through this just so we can get past it. If I were to do this average rate of change for f of x on the second one, I would, I'm going to not show the work, I would also get 5. Looking at the function for f, why do I get the same slope both times as 5? Because this is a what? Straight line. Lines have the same slope no matter where you're talking, okay? So it's constantly going rise 5, run 1, rise 5, run 1. On g of x, it's not going to be the same, okay? I'm not actually going to find the average rate of changes for these intervals, but it won't be the same. Why not? What kind of a function is this? What'd you say? So I heard it. Starts with a Q. Quadratic. And quadratics don't have the same slope the whole time. They kind of change. If you look at the slope over here, it's going to be a negative slope. If you look at the slope over here, it's going to be positive. So it kind of depends on what two numbers you're looking between. Okay? Does that make sense? Whereas linear always has the same slope. So they're just pointing that out. Flip over to the back. We're going to jump to exercise 4, where we're going to find the average rate of change based on a table. And in addition, this is also a word problem. There's a context here. The time of the day and the temperature. Okay, so we're going to talk about the fact that there's a context involved as well. But here the table is showing us our temperature depending on the hour of the day in the summer. They want us to find the average rate of change between 8 a.m., which is here, so that point would be 8, 15, and 10 a.m. That would be the point 10, 19. So our average rate of change, y2 minus y1 is 19 minus 15. x2 minus x1 is 10 minus 8. Now, because there is a context in a word problem, there have to be units. 19, what's the unit on temperature? Degrees, so that's degrees. What's the unit on time? Hours. So when you reduce this, you're going to get 4 degrees divided by 2 hours. And 4 divided by 2 is obviously what? 2. Now your unit when you divide becomes degrees per hour. 2 degrees per hour. Did we all know that that per symbol really is division? Okay, that's where it comes from. I know people don't think of that when they see like miles per hour, but that is division. And it comes because we literally divide the units as well. Okie doke. On this table, we're jumping up, we're going to skip part B there. This is a linear function. And like we said, if it's a linear function, then the slope has to be the same throughout. Nathan Henry question. Just do it at the end, for sure. I did it throughout just so you could kind of follow through. Good question. So here, I'm going to use these two to find the slope. So we've got y2 minus y1, which would be 1 minus negative 5, over x2 minus x1. 5 minus 1 tells me my slope is 6/4 or 3/2. So rise 3, run 2. Okay? So here, if I'm looking for my missing point here, just put a y in there for now, because I don't know what it is. But I do know that because it's linear, if the slope was 3/2 here, it still has to be 3/2. So my slope equals y minus 1 over 11 minus 5, but I don't need to use m as my slope anymore. I know my slope is 3/2. So I'm going to cross multiply to solve this. What's 11 minus 5? 6. So 3 times 6 is 18 equals, when I cross multiply here, I have to distribute. So that's going to be 2y minus 2. And solve, and you'll have your y coordinate. Any questions? Once I have this y coordinate, I will do the same thing when I'm using x. Use the little formula instead of equal to 3/2 again. Okay? So hopefully a pretty easy day, but I will tell you average rate of change has been on every single region in some capacity that we've had so far. So we got to make sure we understand how to use it in like different contexts. You too, thank you. You're up tomorrow? You're ready for it? You all about? Thank you. You're all out tomorrow? One in the meeting. Oh, you just want to get started? What the heck will we do? Tomorrow's piecewise. Piecewise.